Hello everyone, in this session we are going to talk about one problem based on constraint. So here what I have shown you is that there are two blocks of mass m1 and mass m2, and these two are connected to each other with a blue color string over here, and this string is passing over a pulley which is shown by yellow color here. Okay, now the question is that if this particular mass m1 is moving towards left with a velocity v1, then what will be the velocity of mass m2? That is the question. Okay, so then how we will solve that? Before we solve that, I will we introduce one more variable which is given to us, which is angle theta. Okay, here theta is given to us. Now how we will find out the relation between the velocity v1 and velocity v2? So here you can see that if this particular string is going upwards with 2 meter per second, okay, that means this particular part of the string is going in this direction that I am showing here with the arrow with a 2 meter per second speed. Okay, that means by the amount by which the rate at which this particular length is decreasing, the same length is increasing by the amount by which the rate at which this particular string over here is decreasing, the rate of increase for this particular string is also the same. Okay, so because this is a constraint over here. Okay, so that gives us an idea that the speed of this particular string in this direction must be equal to this direction. Now we have said that here the velocity of this particular block is v1. Okay, so if I erase this block as of now, okay, and I will show the block as a point object over here, and this is the velocity v1. Let me erase this surface also, so we will make it simple. So this is v1. Okay, now what is the velocity along this particular blue color string? If I extend this blue color string like this angle between v1 and this blue color string will be theta. So now this is because vertically opposite angles are equal. So now this component will become v1 cos theta. This particular component will become v1 cos theta. So since the block is going towards left with a v1 speed, then v1 velocity, then its component along this particular line will be v1 cos theta, and this v1 cos theta itself must be equal to v2. So I can write over here v1 cos theta is equal to v2. So this is the relation between the velocities v1 and v2. Okay, now the question will be with a numerical value, suppose. So let's say we have, for example, numerical value of v1 to be 2 meter per second and angle theta is 37 degree. Okay, so here I am going to give you one more information. Okay, so if you want to find out the cosine or sine of 37 degree or any trigonometric identity, you use this triangle. Okay, so this is 37, 53, 90 degree triangle. So the side opposite to 37 is 3, opposite to the 53 is 4, and the hypotenuse is 5. So this is 3, 4, 5 triangle. Okay, always remember this the side opposite to 37 is 3. The way to remember is that you can remember that 37 and 3 are having the first digit as common, 37 and 3, and then 5 is the hypotenuse and 4 is the remaining side. Okay, so now v1 cos theta. So what will be the v2, they will ask. So v2 will be v1 cos theta, so 2 into cos of 37 degree. So what will be v2? I don't have enough space here, so I will take this over here and do this. v2 is equal to 2 into cos 37. From here you can see that cos 37 will be 3 divided by, sorry, not 3 divided by 4, adjacent side by hypotenuse, that is 4 by 5. So here it will be 4 by 5. So it is 2 into 5 into 0.8 is 4, so this will be 1.6 meter per second. Okay, if this particular block is moving towards left with a velocity of 2 meter per second, then this particular block will move upwards with a velocity 1.6 meter per second. So this is an example of application of constraint.